So, hello everyone. I am going to solve the quiz which I recently conducted. So, this is the quiz one, and there are some questions which are there in that quiz which we are going to see today. So, on the screen, you can see the first question. A current of minus 6 plus J4 amperes flows through an impedance element. So, basically, I'm going to read the question and we're going to solve it. You can also pause and have a look at the question and try it yourself. And this is a question. So let's start solving it. So the current of minus 6 plus J4 flows through an impedance element having a resistance of 3.2 ohms and inductance of 20 millihenries. So inductance is given and frequency is given 50 hertz. So from that I can find out the inductance reactance, and then finally I can find out the impedance, and impedance multiplied with the current will give me the voltage. Let V of t denote the instantaneous voltage drop across the impedance element. So determine all this. So let's do that. So first thing I have to do is find the impedance. So given resistance is 3.2 ohms and inductance is 20 millihenries. Let me just check that. Yeah, and frequency is 50 hertz. So therefore XL will be 2 pi FL. So this is first question. That is 2 pi into 50 into 20 millihenries. So let me go to my calculator. 2 into pi into 50 into 20 e to the power of minus 3, that is milli. So I'm getting 6.2832 ohms. So 6.28 ohms I take. So here I can use J because it's a impedance. So total impedance will be 3.2 plus J 6.28 ohms. And the current given to be minus 6. Let me refer to the question. Plus J4 amperes. So from this I'll get the voltage is nothing but current into impedance I into Z. So I just multiply these two. Now I can convert them into polar form and then multiply them. It all depends on your calculator. So my calculator I'm using this one. So I define I equal to minus 6 plus 4i, and then I define my impedance Z is 3.2 plus 6.28i. So and then V equal to I into Z. So minus 44.32 minus 28.88. So now I am interested in magnitude and angle. So I would like to convert this into polar. So absolute value of V, and I just want to display the angle of V. And I divide it by 180 and multiplied by pi to convert into radians. So I'm sorry, I have to multiply it by 180 and divide it by pi. So the magnitude is 50.8. So 50.8, and the angle is minus 150.7 degrees. So 0.69 I'm rounding off to 7. This is the voltage. Now the question is, this voltage is RMS voltage. So typically all the values that are given are RMS. So the peak voltage Vmax will be root 2 into Vrms, that is 50.8. So 50.8 into square root of 2 will be 71.8, and this is the maximum voltage. So therefore V of t I can write it as 71.8 sine. So omega is 2 pi f. So 2 pi into 50 omega t, and then phase angle is minus 150.7 degrees. Okay, so this is in radians and this is in degrees, not to confuse. So this is the expression for voltage. Now let's go back to the question. V of t denote the instantaneous voltage drop across the impedance element. Determine V of t at t equal to 10 milliseconds. So that is straightforward. So I have this equation. So at t equal to 10 milliseconds, what is V of t? So again I go back to my calculator. So I'll just write this. So 71.8 into sine of omega, that is 2 into pi into 50 into t. So I have not yet defined what is my t. So t I will define 10 milliseconds, 10 e minus 3 plus sorry, the minus 150.7 degrees. So this is in degrees, I'll convert into radians because the sine function accepts values into radians. So that's it. So here I'm getting 35.138 volts. So the answer is 35.138. So at time t equal to 10 millisecond, the voltage will be this much. Instantaneous voltage will be that much. That is instantaneous voltage drop across the element. So let's go back to the question. At what time instant t will the voltage V of t equal to 0? So at what time instant V of t equal to 0? So V of t is 0. So if this is 0, then from this 70, so 71.8 sine of 2 pi into 50t minus 150.7 degrees equal to 0. So this gets cancelled and sine of something is 0. So this whole thing will be 0 because sine 0 is 0. So therefore from this I will get t equal to 150.7 degrees divided by 2 pi into 50. Whereas the denominator is in radians and numerator is in degrees. So I have to just multiply by pi and divide by 180. So I'll get the time. So let's do this. So 150.7 divided by 2 pi f divided by 2 into pi into 50 and then multiplied by pi and divided by 180. So I'm getting 0.00837 seconds, or I'll write it as 8.3 milliseconds. So this is my second answer. So these are the answers. So this is the first answer. This is the second answer. So that's about the first question. So let's do the second question in the exam. Coming to the second question, if I go back to the question, two AC voltage sources having V1 delta 1, V2 delta 2 respectively are connected by a single line whose impedance is J0.1 per unit. So if I draw the figure for that, the figure would be something like this. So there is a voltage source here. There is a AC voltage source. There is another voltage source here. So this is V1 delta 1, this is J 0.1 per unit, and this is V2 delta 2. So let S1 represent the complex power supplied by source 1. So this is the source 1, S1 is the complex power supplied by the source 1. Different values are given below for voltage and complex powers. Match the voltages with the resulting complex power. So there is some kind of a matching going on here. So 1 to 8 and A to H. So one thing you should understand is here that we had also stressed during the course, that is delta 1 greater than delta 2. So P1 is positive. That is going right side. That is when delta 1 is greater than delta 2. Otherwise, if delta 1 is less than delta 2, then the P1 is negative, or the direction is like this. It goes without saying. So this is one thing. Now look at V1, V2. So V1, magnitude of V1 is greater than magnitude of V2. Then the reactive power goes from Q1 is positive. That is, it goes like this, reactive power. If V1 is less than V2, then the reactive power is negative and it comes back like this. So that is what is the this one. So active power flows from higher delta to lower delta. Reactive power flows from higher voltage to lower voltage. Based on these two itself, we can answer this question. So look at the choices here. So one of the choices we find here is 0, 0. So when does that happen? So 0, 0 happens when both voltages are equal and both angles are equal. So let's look for the choice that is there. Look at the last one, 0.95 voltage, 0.95 voltage, angle is also same. So V1 delta 1, V2 delta 2 are same. So 8 must be D. So, so let's match them. I have 1, 2, 3, 4, 5, 6, 7 and 8. So 8 is D. So we are done with D. Next, what we have? Here you see 0. That means the active power is 0. So when will the active power be 0? When both the angles are equal. So now again look at this, angles are not equal for each of these, except the last two, seventh one 3 degrees and 3 degrees, and eighth one also 2 degrees and 2. But eighth one is just taken. So seventh one 3 degrees, the angle is same, but the voltage here is higher. So reactive power will be positive. So that's what we can confirm from here. So therefore 7 is H. Now let's look at the other choices. So let's start with the first one. So here 0 and minus 2. So minus 2 is less. So active power will be positive. So for the choice 1, I should look at all the answers where active power is positive. So and if I look here, I'll get A, B and E and G. Whereas you look at the voltage is less and the V2 voltage is more. So reactive power will be negative. So I am looking for a positive negative combination for the first one. So positive positive, this is not the answer. So B may be the answer, positive negative. Similarly, E may be the answer, B or E. That is for the first one. So B or E. Now, B or E, you notice the amount is more for E and less for A. So we'll just keep that in mind. Now come to the second one. So second one is exactly same, except that both will be positive, because here the voltage is 1 and here the voltage is 0.9. So reactive power will be positive and active power also will be positive. So both positive, I have A and I have G. So A and G are the candidates. So let's write like that. Now coming to the third one. So look at the difference in the angle. So third one is 4 degrees difference in the angle, and then this is also there. So the reactive power will be negative, because sorry, the active power will be negative, reactive power also will be negative, because delta 1 is less than delta 2 and V1 is less than V2. So both will be negative. So out of all this, only F is the choice that is comparing. So 3 should be F, because both active power reactive power are negative. So 3 is F. Now you notice one thing, the difference is 4 degrees. Minus 2 to plus 2 difference for 4 degrees, active power is about 0.6. So therefore, if the difference is only 2 degrees, the active power will be half of this. And you notice that here it is half. So 6 to 7, 8 half, if you do approximately, it will come to this. So answer E will match to something where the angle difference is only 2 degrees. And again you notice that here for 1, the angle difference is 2 degrees. So E should be the answer for 1. B cannot be the answer because 0.165 is again half of this, looks like. So it should be only for 1 degree difference. So B is not the answer here. So E is the answer for A. So 2 degree represent 0.314 of active power, and 4 degree difference represents 0.6278 of active power. You see that. So therefore 1 degree would be 162 something like that. So 1658 is here. So now come to 4. So the angle difference is 4 degrees, and so therefore I am looking for 0.672 and it is negative, so I can rightly match C. So 4 is C. What about 5? 5, only 1 degree is the difference, and then the active power will be positive because this one. So the candidate would be only A or B, and then I think B is the correct answer here because not B. Both should be positive. So I think A is the correct answer. So here A is the correct answer. So therefore here A cannot be the answer. G is the correct answer. F is already gone. So A, only B is left out. So I think this is the final this thing. Let me just check whether 6 and B are okay. Yes, reactive power is negative, active power is positive, so everything looks fine. So of course you can also calculate it and do it, but without calculator, just by observation you can answer this question. So this is the answer for question number 2. So let me mark the answer. This is answer for question 2. So 1E, 2G and so on. Let's come to question 3. So what is the question? So the question is something like this. Determine the Thevenin's equivalent voltage and Thevenin's equivalent impedance for the network when viewed from terminals A and B shown in figure 1. So this is my figure. Now I have to find the Thevenin's equivalent between the terminals A and B. So how do you find Thevenin's equivalent? So first is I'll find Thevenin's impedance. So you short circuit this and short circuit this. So I have two impedances connected in parallel. So Thevenin's impedance will be the resultant impedance. 2 minus J5 and 1 plus J2. So this is third question. Thevenin's impedance. So I just short circuited both the sources. So I get a system like this. This is A, B, and this is Z1, this is Z2. So Z Thevenin is nothing but Z1 parallel to Z2. So that is nothing but Z1, Z2 by Z1 plus Z2. So let's go to my calculator. So I define Z1 equal to two minus J5 and Z2 is 1 plus J2. So now I have ZTH equal to Z1 into Z2 divided by Z1 plus Z2. As simple as that. 2.167 plus J 1.833. So this is my Thevenin's impedance. Next, I want to find the Thevenin's voltage. So to find the Thevenin's voltage, you have to find the open circuit voltage between these two terminals. So let me add the sources also back. So I have like this plus minus. Here I have Z1 plus minus, and here I have Z2. Now I want to find the voltage between A and B, open circuit voltage between A and B. So the values are 50, 0 degrees, and here it is 60 angle 30 degrees. So first I want to find the current. So let's write the current here. So current will be net voltage by net impedance. So because everything is in series. But notice that two positive terminals are facing each other, two negative. So these two voltages are opposing each other. So if I consider my current direction to be this one, then So the current is leaving the positive terminal here. So this would be positive. So 60, 30 degrees, and then minus 50, 0 degrees. This is the total voltage divided by total impedance. So this will give me the current. And once I have the current, then that current, if I multiply with Z2 once again, so that is nothing but VAB. Whatever is the current multiplied by Z2 will be VAB. And I know that A will be the higher voltage because the current is going from A to B. So this is what I have to do it. Excuse me. So let's go to my calculator. So I define V1 as 60 at an angle of 30 degrees. So this is how I define V as a complex number. Luckily V2 is just 0 degrees, so it's 50, just 50 I can use it. Now I want V1 minus V2 divided by Z1 plus Z2. This is the total current, and this entire thing is multiplied by Z2 will be the voltage drop. So minus 15.32 minus J 4.01. So let's convert this into polar form. So I'll store this as VTH. So absolute value of VTH and angle of VTH converted into degrees. So here I am getting 15.84 at an angle of minus 165 degrees. So this is my voltage, Thevenin's voltage. So let me create the Thevenin's equivalent network. So I have VTH equal to 15.84 angle minus 165 degrees, and then ZTH, which I have the value. So this is my terminal A and terminal B. This is Thevenin's equivalent. So what is the value of ZTH? 2.167 plus J 1.833 ohms. So finally this is the answer for the third question. Okay, so let's continue. Let's do the fourth question. This is the fourth question in the exam, the last one you can see below. Determine the total complex power output of the three-phase source shown in the figure. So you see there's a three-phase three-wire system supply here, supplied by a 20 volt per phase three-phase supply. So basically I can directly see here line voltage is 20 volts because this is delta connected. Next I have a delta connected load and I have a star connected load. So to find the power, what is a complex power? It's nothing but determine the total complex power output of the three-phase source. So to find the power, I need to know both the currents. So the line current here and line current here, I will add it. Line current here I can easily get it because for this delta to delta, so whatever 20 volts divided by 1 plus J2 will be the line current here. And here the phase current I will get it, and then from that I will get the line current. So how to get the phase? I have to divide 20 by root 3 to get the phase voltage, then this impedance, then I get whatever is the current, that will be the line current. So just see here, line current of delta load. So what is the line current of delta load? 20 volts divided by 1 plus J2. Line current of star load. So first I will do 20 by root 3. So this will give me the phase voltage. So phase voltage divided by the impedance is 2 minus J5. This will give me the phase current, but phase current itself is the line current of the this one. So now if I add these two, then I'll get the total line current. So total line current of the supply. So let's define it as IS. So let me do that quickly. So 20 divided by 1 plus 2I, this is one current, plus 20 by square root of 3 divided by 2 minus 5I. So I hope it's all correct. So this is the answer. So let's store it into a variable. Let's call the variable IS. So this is a supply current. So let's get the angle and absolute value. So absolute value of IS and then angle of IS into 180 divided by pi. So 7.68 and then minus 51.4 degrees. So once I have the current, so what is this is the line current, total line current of the supply. So what is the complex power? This is nothing but root 3 VL IL. So root 3 into the line voltage is nothing but the phase voltage because it's a delta source, and the angle assume it to be 0. So 7.688 and the angle will be minus 51.4 degrees. So let's do this now. So square root of 3 multiplied by 20 multiplied by 7.6886. So 266.34 watts or volt amperes at an angle of minus 51.4 degrees. Now I can again convert this into real and imaginary parts. So I get 266.34 multiplied by exponent of I into my angle is minus 51.4. So divide by 180 multiply by pi to convert into radians. So I am getting 166 minus 208. 166.16 minus 208. This is J 0.15. So this is watts and this is wars, and this total is volt amperes. So this is the complex power supplied by the load, supplied by the source. So this is the final solution for the fourth problem also. So thus this question, the quiz which had only 4 questions. So I have answered all the questions in this quiz. So I hope the total time given was I think 1.5 hours, but then I think we had done it within the time. So I hope you now understood how to solve this kind of quizzes. There are going to be 2 more quizzes in this course. So hopefully this will help you do the other 2 quizzes nicely. Thank you.